Hello viewers, today we start elements of abstract algebra and this is an interesting topics, and we discuss today the set theoretic preliminaries of the few ideas about permutations. And if we are study with the notations of the permutations, it is in the form of like this, like the notation of the matrix, like this A1, A2 in this way, and somehow in between them we find AI, and if up to dotted structure at last AN, and corresponding to B1, B2 up to BI and here BN. It is our notations, and if we denote by definitions, we are finding here in this way like this. This f of A1 is B1, f of A2 that will be B2. In this way we find f of AI is equal to BI, and in the structures finally we find f of AN is equal to BN. So what happens there? And we finally find a relationship A1 and f of A1. So if we are writing structurally in the revised mode, what we find? A1, A2, here AI up to AN. Corresponding to that, we find it here f of A1 replacing a B1 by f of A1, here f of A2, here f of AI up to f of AN. So it is easily observable that it's a mapping. And what will be the nature of the mapping? The nature of the mapping, it must be 1 to 1 as well as 1 to. So 1-1 mapping is there of the finite onto itself. That means A1 is mapped onto this. That is, images have some pre-images we only find, and 1 to 1. It's clear. If f of A1 is equal to f of F2, then it is easily clear that A1 will be A2. And it's conclude the definitions as 1-1 and onto mapping onto itself. So if we finally form a definition of permutation, we can write as a 1-1 mapping of finite set onto itself. That means here A1 and we get P images A1. That's why is called a permutation. And already know this permutation 1-1 and 1-1 onto mapping is invertible, so we can easily find the inverse of these things, no problem for that. Now we are cited few of the example of the permutations like this. If we cite the example, like this, whatever may be, different type of arrangement in permutations. etc. etc. We can define this type of ideas. Now we have to know how to make a product of permutation. Let's watch. What is this? If f is given by, suppose 1, 2, 3, 4, 5 in this manner, and 1 is mapped onto 2, it is 3, it is 1, it is 5, and it is 4, and g is given 1, 2, 3, 4, 5, and here it is 1, 5, 4, 3, 2. Then how to find FOG? So to find FOG, we are making a product by different process. Let's watch what happens. Here product of the permutation is given by 1 is mapped onto 1. So we are starting with the convention FOG. That started G is right side of F. F is the left side. So we find it here from right to left notation. 1 is mapped onto 1 and this one is mapped onto 2. So 1 is mapped onto 2. Product definition. 2 is mapped onto 5. Here 2 is mapped onto 3. So finally find 2, 5 and 2 is mapped onto 5, 5 is mapped onto 4, so 2 is mapped onto 4. Now 3 is mapped onto 4, 4 is mapped onto 5, so we write here. 4 is mapped onto 3 and 3 is mapped onto 1, so 4 is mapped onto 1. 5 is mapped onto 2 and 2 is mapped onto 3, so 5 is mapped onto 3. In this way we find. And corresponding, if we watch what happens there, if we find GOF, what happens there? Then we calculate from this side. F is the first, given first priority. 1 is mapped onto 2 and 2 is mapped onto 5, so 1 is mapped onto 5. 2 is mapped onto 3 and 3 is mapped onto 4, so 2 is mapped onto 4. 3 is mapped onto 1 and 1 is mapped onto 1, so 3 is mapped onto 1. 4 is mapped onto 5 and 5 is mapped onto 2, so 4 is mapped onto 2. 5 is mapped onto 4 and 4 is mapped onto 3, so 5 is mapped onto 3. So we find here this type of structure. We evaluate separately FOG and GOF. So it is also noticeable that here it is observable FOG is not equals to GOF. So in this way we find its result of a permutation. Now we find the inverse of the permutation, but already we have done composition of product of permutation. Actually this is a composition product, already we have done. Now we find the inverse of the permutations. How to find this inverse? F is known here. If we taking this structure, similar structure F, 1, 2, 3, 4, 5, 2, 3, 1, 5, 4. We are going easy tricks. If we are finding F inverse, it is easy just to changing the row element. If we find it here, that is 2, 3, 1, 5, 4 and 1, 2, 3, 4, 5. We write row wise. Then we simply rearranging these terms. That is, we are writing the proper order 1, 2, 3, 4, 5, and we arranging them similar order of the mapping. 1 is mapped onto 3, we write it here 3. 2 is mapped onto 1 is mapped onto 3, 2 is mapped onto 1. Now 3 is mapped onto 2, 4 is mapped onto 5, and 5 is mapped onto 4. So we find easily the inverse element. And if we verify it, it is easily verified. FOF inverse, if FOF inverse is identity element, then answer will be correct. How to check it? We are starting with F inverse. 1 is mapped onto 3 and 3 is mapped onto 1. So 1 is mapped onto 1. 2 is mapped onto 1 and 1 is mapped onto 2. So 2 is mapped onto 2. 3 is mapped onto 2. 2 is mapped onto 3. So 3 is mapped onto 3. 4 is mapped onto 5 and 5 is mapped onto 4. 5 is mapped onto 4 and 4 is mapped onto 5. So it is clearly identity and the result is correct. So inverse of this element is this. So in this way we easily find this inverse, and similarly it is clear, and directly we can find easily the inverse of G also. Here also the same cases 1, 2, 3, 4, 5, exchanging this and maintaining this proper order, we are getting this result. So in this way we find compositions of permutations and also find the inverse. In next day we study cyclic permutations. We end our discussions here. If you like this video, like it, share it, and always subscribe the channel and press the bell icon to get all of my notifications. Let's watch, and thanks for watching.